See, for every square matrix capital N, let capital A is equal to matrix Aij of order n by n. Capital A is a square matrix. We can associate a number that is either real or complex is called a determinant of the square matrix capital A. So that is denoted by determinant of A. Determinant of capital A is denoted by like this, or determinant of A. Determinant of A. For every square matrix, we associate a real number. We associate a real number or complex number. That is called the determinant. See, this can be expressed as a function. Let m be the set of all square matrices. Square matrices. Let capital M be the set of all square matrices. So we can associate for each capital M there is a number. Let k be the set of numbers. Let k be the set of numbers. That numbers are either real or complex. So then this determinant is a function. Then the determinant is a function. Let f be that function. Determinant is a function from capital M to this set of numbers. That is, for every square matrix, we associate a number that is either real or complex. That is called the determinant of the square matrix. Now we can find, how will you find the value of a determinant? Value of a determinant, that is the value of a determinant which is associated to each square matrix. So determinant of a matrix of order 1. Let capital A. Let capital A is equal to matrix A11. A11. That is a 1 by 1 matrix. So determinant of A is equal to determinant of A11, which is not the modulus, that is A11. Not the symbol is not the modulus. Okay. So determinant of A is determinant of A11, that is A11. That is the determinant of a square matrix of order 1. Now determinant of a square matrix, consider A is equal to a square matrix 2 by 2 square matrix A11, A12, A21, A22. That is the 2 by 2 square matrix. What is the value of this determinant of this matrix A? Determinant of A is equal to determinant of A11, A12, A21, A22. So this determinant is the product. See this product, A11 into A22 minus A21 into A12. Okay, that is the value of the determinant of order 2. Now we can find the determinant of a square matrix of order 3. See, consider a 3 by 3 matrix. Consider a 3 by 3 matrix. A is equal to matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. That is a 3 by 3 matrix. 3 by 3 matrix. Now we can find the determinant of A. Determinant of A is equal to determinant of A11, A12, A13, A21, A22, A23, A31, A32, A33. That is a 3 by 3 matrix and the determinant. Now we can expand the value of the determinant along the first row. We can expand along the first row, we can expand along this second row, we can expand along the third row, or we can expand along first column, we can expand along the second column, and we can expand along the third column. Now we consider the expansion along the first row. Expansion along R1, expansion along the first row, expansion along the first row. See, the elements are determinant of A is equal to, how will you expand this determinant? Determinant of A is equal to A11 into A11 into. See, here A11 means there is a positive sign. So this positive, this sign of this A11 depends on this suffix 1 and 1. So here minus 1 raised to 1 plus 1, minus 1 raised to 1 plus 1 into A11 plus next is minus 1 raised to 1 plus 2 into A12 minus 1 raised to 1 plus 1 into A11 into, now we take the value of the determinant deleting the row containing A11 and the column containing A11. See, the row containing A11 is the first row and the column containing A11 is the first column. So delete the first row and first column, so we have these four elements. So we can write the value of that determinant A22, A23, A32, A33. So that is the first term of the expansion. Okay. Now plus minus 1 raised to 1 plus 2 into A12. So there forms a negative sign. Negative sign. Minus 1 raised to 1 plus 2 into A12. Now we write the value of the determinant deleting the element, the row containing the element A12, that is the first row, and the column containing the element, that is the second column. So we have these four elements A21, A23, A31, A33. Okay, so that is the second element. Now next term is plus minus 1 raised to 1 plus 3 into A13. So if you delete the row containing A13, that is the first row, and the column containing A13 is the third column. So we have these four elements A21, A22, A21, A22, A31, A32. Okay. So which is equal to, so the first one, determinant of A is equal to, which is positive, A11 into determinant A22, A23, A32, A33. So for the second minus 1 raised to 1 plus 2 minus 1 raised to 3, that is negative a12 into determinant a21, a23, a31, a33 plus here minus 1 raised to 1 plus 3 minus 1 raised to 4, that is positive a13 into determinant a21, a22, a31, a32. So that is the value of the determinant expanding along the first row. Now we can expand this determinant along the second row. We can expand along the second row. Expansion along R2. Determinant of A is equal to R2. See, in this R2, we have first element is A21. So we have minus 1 raised to, the suffix is 2 plus 1, minus 1 raised to 2 plus 1. So first minus 1 raised to 2 plus 1, so that is, there forms a negative sign. So if you expand along R2, we have, when we choose the first element A21, there is a negative sign. So negative A21 into, now the value of the determinant, deleting the second row A21, the row containing A21 is the second row and the column containing A21 is the first column. So we have the elements A12, A13, A12, A13, A32, A33. So which is equal to, that is determinant deleting the first, second row and first column A12, A13, A32, A33. Okay, minus A21. Now next is plus A22 into determinant. Deleting the second row and second column, we have A11, A13, A31, A33. Now next sign is negative, minus A23 into determinant, deleting the second row and third column, A11, A12, A31, A32. So that is the value of the determinant if we expand along the second row. Now we can expand this determinant along first column. Expansion along C1, first column. Determinant of A equal to first column A11, so that is positive, A11 into deleting the first row and first column A22, A23, A32, A33. Now for the second element A21, there is negative sign, A21 into determinant A12, A13, A32, A33 plus A31 into determinant, deleting the third row and first column A12, A13, A22, A23. So that is the value of the determinant if we expand the determinant along the first column. The value of the determinant cos theta sin theta minus sin theta cos theta. This is a 2 by 2 determinant. So the value of this determinant is product of cos theta and cos theta, that is cos theta into cos theta minus this product. This product is minus sin theta into sin theta, which is cos square theta plus sin square theta, which is equal to 1. So that is the value of the determinant. Okay. Determinant 3 minus 1 minus 2, 3 minus 1 minus 2, 0 0 minus 1, 0 0 minus 1, and 3 minus 5 0. 3 minus 5 0. Now we can expand this determinant along the second row. Since second row containing first two elements are zeros, which is very easy to expand along the second row. So when we start with the first term, there is a negative sign. So negative sign into 0, negative 0 plus negative 0 into, see, negative 0 into the value of the determinant, which is equal to, there is a negative sign, negative 0 into value of the determinant, deleting the second row and first column, that is minus 1, minus 2, minus 5, 0. Okay, now plus 0 into, first is negative, plus 0 into, there is also deleting the second row and second column, 3 minus 2, 3, 0, plus minus 1 into, first one is negative, second one is positive, again negative, now minus 1 into determinant, deleting the second row and third column, 3 minus 1, 3 minus 5. So first term is 0, second term is 0, plus 1 into cross product, 3 into minus 5, 3 into minus 5 minus 3 into minus 1. So that is minus 15 plus 3, minus 15 plus 3, that is minus 12. So minus 12 is the value of the determinant. Okay. Now consider the problem. A is equal to matrix 1 1 minus 2, 2 1 minus 3, and third row is 5 4 minus 9. We have to find the value of the determinant. So we can expand this determinant along the first row. Determinant of A is equal to, first row 1 into, deleting the first row and first column, we have 1 minus 3, 4 minus 9. Now next is negative sign, negative 1 into, deleting the first row and second column, the row containing the element and the column containing the element. So 2 minus 3, 5 minus 9, plus third element is minus 2 into the element containing first minus 2, that is first row, first last column. So 2 1 5 4. Okay, so which is equal to 1 into, which is minus 9 minus minus 12, minus 1 into minus 18 minus minus 15, minus 2 into 8 minus 5. Okay, so that is 1 into minus 9 plus 12, 3, minus 1 into minus 18 plus 15, that is negative 3, minus 2 into 3, so that is 3 plus 3 minus 6, 3 plus 3 minus 6, so value of the determinant is 0. If determinant 2 4 5 1 is equal to determinant 2x 4 6 x, then find the value of x. So expanding, determinant is expanding, left hand side expansion is 2 into 1, 2 into 1 minus 5 into 4 is equal to 2x into x minus 6 into 4. Okay, now 2 minus 20 is equal to 2x square minus 24. Now 2 minus 20 is minus 18 plus 24 is equal to 2x square, or 2x square is equal to 6, or x square is equal to 3, x is equal to plus or minus root 3. Determinant x to 18x is equal to determinant 6 to 18, 6. Then the value of x, see, expanding, we have x square minus 36 equal to 36 minus 36. Okay, so x square equal to 36, x is equal to plus or minus 6. So this type of problem can be done like this. We can find the value, or we can solve. Solve means we can find the value of x. Okay. Delta is equal to determinant a1, b1, c1, a2, b2, c2, a3, b3, c3. And delta dash is equal to delta dash. Delta dash is obtained by, delta dash is interchanging the rows and columns. That is, first row become first column, a1, b1, c1, a2, b2, c2, and a3, b3, c3. If we expand these two determinants, we can see that this delta and delta dash are same. So delta is equal to delta dash. If the rows and columns of a determinant are interchanged, the value of the determinant cannot change, or the value of the determinant is same. That is, if A is a square matrix, then if A is a square matrix, then determinant A is same as determinant of A transpose. Determinant A and determinant A transpose are same. Let delta is equal to a1, b1, c1, a2, b2, c2, a3, b3, c3. Now delta dash is equal to determinant. Here we interchange this first row and second row. That is a2, b2, c2, a1, b1, c1, a3, b3, c3. So in this case, this delta is equal to minus, this delta dash is equal to minus delta. That is, when if we interchange any two rows or any two columns of a determinant, then the sign of the determinant changes. If delta is equal to, so assume that if delta is equal to k, then delta, if we interchange the first row and second row, then delta dash become negative of k. Or if we interchange the first two columns, if we interchange any two columns or any two rows, the value of the, or the sign of the determinant changes. Okay, that is the second property. Third property, delta is equal to first row a1, b1, c1, second row is also a1, b1, c1, and third row is a3, b3, c3. Here the value of the determinant is 0. That is, if any two row, if we expand this determinant, you can see that the value of the determinant is 0. That is, if any two rows or columns of a determinant are identical, the value of the determinant is 0. If any two rows are identical, value 0. If any two columns are identical, value of the determinant is 0. Okay. Now the next property, let delta is equal to determinant a1, b1, c1, a2, b2, c2, and a3, b3, c3. Now form another determinant that is obtained by multiplying the first row by a scalar k a1, k b1, k c1, a2, b2, c2, A3, B3, C3. If the first row is multiplied, first row, the elements of the first rows are multiplied by a constant, then which is equal to K into delta, K times the value of the determinant delta. That is, if each element of a row or a column of a determinant is multiplied by a constant K, then the value gets multiplied by K. Next property, delta is equal to determinant. Here the first row, A1 plus lambda 1, A2 plus lambda 2, A3 plus lambda 3, A2, B2, C2, A3, B3, C3. Here the first row is the sum of two terms. If the first row or any row is sum of two or more terms, then this determinant can be expressed as the sum of two or more determinants. Here the first row is the sum of two terms. So this determinant can be expressed as sum of two determinants. Here A1, B1, C1. Here lambda 1, lambda 2, lambda 3. Second row no change, A2, B2, C2. Here is also A2, B2, C2. Third row A3, B3, C3. Here is also A3, B3, C3. So if any two row, or if any row, no, not two rows, if any row or column is the sum of two or more terms, then the determinant can be expressed as the sum of two or more determinants. Next property. Let delta is equal to determinant A1, B1, C1, A2, B2, C2 and A3, B3, C3. And we form another determinant delta dash is equal to, see this first row. This first row is first row, elements of first row plus a scalar into second row. B1 plus K into B2. C1 plus K into C2. A2, B2, C2, A3, B3, C3. So that is the new first row. The new first row is obtained by, new first row is first row plus a scalar into second row. That is the new first row. We form a determinant using this transformation. Now what is the relation between this delta and delta dash? See, a scalar multiple of second row is added to the first row. The corresponding elements are added. The scalar multiple of the corresponding elements of the second row is added to the corresponding elements of the first row. We make another determinant delta dash. Now what is the relation between this delta and delta dash? So the relation between this delta and delta dash is, see, which is equal to, see, the first row is the sum of two terms. Since first row is the sum of two terms, this determinant can be expressed as the sum of two determinants. Since the first row is the sum of two terms, this determinant can be expressed as the sum of two determinants. So first row here A1, B1, C1, A1, B1, C1, first row. Here the first row K, A2, K, B2, K, C2. Now second row now change A2, B2, C2. Here is also A2, B2, C2. Third row A3, B3, C3. Here is third row A3, B3, C3. Now the first one is delta. First one is delta plus. For the second one, K, for the first row, K is common. K into A2, B2, C2. A2, B2, C2, A3, B3, C3. Here the first row and second row are same, so the value of the determinant is 0. So delta plus k into 0, which is equal to delta. So here delta dash and delta are same.